All right, let's look at this first question. So simple interest rate. So simple interest is just the amount multiplied by the interest rate as the decimal, multiplied by the number of years. This will only give us the interest. It will not give us the final amount. But I think, so 24. So the value of the investment is 224. I got to add that 24 back on. Second, yeah. No, I've given them all up. I'll print more after. Okay, so the second one then is compound interest. Compound interest slightly different. We got to go to the power of. So 200. The interest rate in compound interest, I got to write 1.014 and 8 years to the power of 8. I use a power instead of a multiply. So 200 multiplied by and I get 223.53 or so. Okay, so it's money, so I round it to 2 decimal places. Okay. The rates remain the same in part A and part B. Find out how many more complete years it will take Lena's investment to be greater than Carl's investment. So they're pretty close already, aren't they? So, Levi, what are you doing? Yeah. If the interest rates remain the same, you may imagine that the next year it would be the same, or they'd cross over. How many more complete years? But how would I work it out in general? You could try and error it, yeah. So this is the simple interest. If you want to do it mathematically or otherwise, this is the compound interest, but I don't know the number of years to the power of n. So I got 2 equations here. I can try and error this, or I can use my calculator and graph the 2 and see where they cross over. We're going to graph these 2. Okay, my window is way off, but I will change the window in a second. Talia, bit loud. Okay, so I'm going to change my window because clearly this is way too big. So the interest rates we're dealing with are given around 100 or 200, so I'll regraph it. These lines look pretty parallel. What am I expecting? Perhaps I typed it in wrong. I've definitely typed it in wrong. I think it's 1 more year, isn't it? Trial and error. I've tried to show it, but I've typed it in wrong. It's going to be 1 more year. You can see how close these are here. If you just trial and error and do 1 more year, complete years. How many more complete years? 1 more. Is it not 1 year? Is it 47 cents off? Yeah.
Well, don't you just look at the 2 actions you got?
Well, I'm looking at the 2. All right, I'm going to do it. All right, I got lazy and I didn't do it, but here it is. 9. So 227 is the next year with simple interest. With compound interest.
Oh, wait, is it what the value
is 11, is it? Oh, it doesn't cross yet. You're right.
Oh, that's what
Okay, so this is 9 years. That's year 9, so it just hasn't crossed over yet. So you're saying year 11 is the first year? So you'd have to keep doing this. I just presume they're about to cross over. Charlie. So 2, 3, 3 in year 11. Change this to 11 as well. Yes, it does. It crosses just barely. 233.04. So 3 more years. I was wrong. 3 more years. Okay, so question 2. How do I do this? First things I need to do is plot it on a graph. So I would press y equals, clear out anything else I had that was in wrong. Yeah. Oh, thanks. 2x squared. Sorry, this is going to take a second. 3x, close bracket, divide by. So you should be already thinking where the asymptotes are going to be. I think they're going to be at -2 and 3, looking at the equation. I'm going to change my window so it meets these. So -6 and 6. And -6 and 12. And then I'm going to press graph, and it should give me a weird looking function, I think. Okay, so sketch it then. Oh, it goes underneath and then comes back up. Something like that. Okay, so I sketched it. Find the local minimum. That's this point here. The local minimum will be that point there. How do I do that? I press second trace on the calculator. I go to minimum. I go to the left of it. I go to the right of it. My arrows. And I press enter twice. The local minimum is given to me then 0.930 and minus 0.252. Equation of the two asymptotes that are parallel. That's these two lines. You should be able to get that from reading this. If x was,
Should we do 3 numbers?
it's only, no, they're only asking for the parallel to the y-axis.
I mean, like, how many do we?
Oh, 3 significant figures, yeah. Yeah. Right, there's 2 ways we should be able to get this. Liwa, quiet please. There's 2 ways we should be able to get that. Just from reading the function, if x is -2 and if x is 3, that will make zeros here at the bottom. Yeah. So x equals -2, x equals 3. There's a little cheat here I'll show you now. If you press second table, it'll tell you where they are. If you press second table, just to confirm, where there's an error, x is -2, and these are all points along it. So if you press second, then table, I'll do that again. I'll quit out of this. Second table, and you get the table of all the values in your function. So where it says error is where the asymptotes are. So it's 3 and -2.
So what do you do?
Second graph, it'll give the table of your. Okay. But you can just do it. It's as easy just to read it off this. Second graph gives the table, might be useful if you can't find the asymptote. All right, next one. G of x is this new function, so I'm going to draw it. 3x plus 2. I'll draw it and look at the graph, and it goes through 1, 2, 3 times. It goes through 1, 2, 3 times. Solve where they're equal. There's going to be just 3 marks, and that's for each of those intersections. I'll just do one of them. To find an intersection, I go down to number 5 here. I go to the left of it, go to the right, and I'll find one of those points of intersection. So x is -0.746. That's 1 point. There's 3 points. You find all 3. Oh no, I'll have to find all 3 for the next part. let's found that one again.
So fx equals gx and the intersect.
Yeah, where two things equal each other is the
Do we
intersect.
both intersect?
There's three.
Oh, right. Do we plot all three?
You don't need to plot all three. So there's a line going through like this. You just need to say what they are. I'm working them out here using the intersect on the calculator. So I go down to number 5. I have one left to find. That's the one up at the top. We'll get there eventually. Uh, 2.53. Okay. There's the 3 I found. So there's a line going like this. And I found these 3 intersects. Where's f of x above g of x? This is a tricky one. Where is f of x above g of x? So which is the f of x function? That's the curvy one. Where is it above? Well, you can kind of highlight it here. I'll use a different color. It's above here, up to this point. Before this point. After this point. See that? Otherwise, the g of x function is above the other one. Well, there's a few things I have to write here. Yeah. So what's this point? That was your first for this one, minus 2 points. So before that, when x is less than minus 2.12, it's above. Now I have to show this one, but from here to here. That's tricky. From the asymptote to here. So between the asymptote, which is at minus 2, up to this one, which was minus 0.746. That's the second place. And then this one is from this point. Oh, I can't see that. This point up to the asymptote. So that's the third place. So that point I found on my calculator to be 2.53 up to the asymptote, which was 3. So that's quite difficult maybe to visualize, especially on a weird function like this, where one is above the other. Yeah. Oh, the answers, yeah. So there's 3 answers. Before minus 2.2, between these two, between these two. Very difficult final question, that. Okay. I'll move on to question 3. Anton, what are you doing? Dimon, what are you doing? Okay. All right. Find h with 0 in. So this is h. It's an absolute value function. I'll just do the working out up here. H with 0 in is 0 squared minus 4, which is minus 4. These absolute value brackets make that positive. It's its distance from 0. So it's just 4. So this is a composite function. You have to sub fx into gx. So gx is 3x minus 2. I'm going to sub in 1 minus x into that. So that x has been replaced by this, and just work it out a little bit. And I think it's just 1 minus 3x when I work that out. Gx times fx, that's 1 minus x times 3x minus 2 plus kx, which is this one, 3x squared plus 2. So I need to multiply this out. So I get 1 times this, 3x minus 2, minus x times that is minus 3x squared, plus 2x, plus 3x squared, plus 2. I need to simplify this. I think the 3x squareds disappear. I've got 5x from those two. And 2 minus 2 also disappears, so I'm just left with 5x. F inverse. So I'll just do that down here. If I'm looking for the inverse, here is the original function. I need to swap x and y. And now solve for y equals. So I can have x minus 1 is equal to minus y, but I want a positive y. So perhaps bringing everything to opposite sides will help. Y over here and these over there, and I think I get 1 minus x again. It ends up being the same. Next one, solve for x when g of x is equal to 2. So I know that 3x minus 2 equals 2. Solve for x. Find what x value makes this. So if I add 2 over to this side, I get 4. So x must be 4 over 3. It's just solving that, dividing by 3. H of x is equal to 3. So this is a little bit trickier. I have an absolute value equal to 3. The way I would do this is I would say that this could equal either positive or negative 3 and work out the two answers. So x squared minus 4 could be 3, or it could be negative 3. I'm not sure which one it was, because that's what absolute value does. It's distance from 0. So 3 and negative 3 are both 3 from 0. So I work out this, x squared is equal to 7 from here. So x is equal to the plus or minus root 7 from this one. This one gives negative 7. X squared is equal to, it gives 1, not negative 7, 1. So x is equal to square root of that is plus or minus 1. So what are my values? X can be plus or minus root 7 or plus or minus 1. Because absolute value is its distance from 0. So it says that the distance of this from 0 is 3, which means it could be 3 on the negative side or 3 on the positive side. Yeah, that's what absolute value means. It's distance from 0. It's like saying, what's the absolute value of negative $1,000? It's $1,000. It's still worth that. You might owe it, but it's still worth $1,000. It's kind of based off that principle. All right. Okay, so our first transformations question. I feel a rotation coming on. So y minus 1, where's the line, or y positive 1? Where's the line y positive 1? Well, it must go through where y is positive 1. So that's here. So it's that line. So it goes through where y is 1. So then I look at the distances. This is 3 boxes, so its buddy must be 3 boxes. This one's 3 boxes, 3 boxes. This one 5 boxes, so 5 boxes, and so on. So you end up with the reflection looking like this. Okay, so your A should have been up here. B is a clockwise rotation, point minus 1, 1. So minus 1, 1 is minus 1 on x and 1 on y, so that's here. Okay, I have another shape drawn on this, but ignore it. Okay, I draw that shape. And I rotate it which way? I rotate it clockwise, the way the clock goes. That's that way. So we end up here. So I put in the corners to make it easier for myself. And then I should probably use a ruler to do that, but I'm in a bit of a rush. So that's B. Next one. Describe a transformation that maps A onto B. So A onto B. That looks like a reflection in this line. What's that line called? Y is equal to minus x. Okay. Next one. Describe fully a transformation that maps P onto Q. P onto Q. Right. This looks like an enlargement, but where's the center? I know it's an enlargement. It's an enlargement. First of all, I can say enlargement. Scale factor looks like it's half maybe. But it's not our normal one because it's kind of going backwards on itself. So what I do is I would join up these points and see where they intersect for the center. So this one has moved to here. Is it P onto Q? This one has moved to here. This one has moved to here. This one over here, that was on the long side, is over here on the long side. And this final one is over here now. So we see our lines meet here. So I know the center is 0, 0. What's the scale factor? Tim? -2? Close? You're presuming it went from Q to P, but I think it actually goes from P to Q. P, so it's minus 0.5. If it goes backwards on itself like this and goes through, if the center of the enlargement's in the middle, then it's a minus center of enlargement. So watch out for that one. So what to do if it's looking like this is draw these lines. Normally our enlargement is like here to here, and we go this way. And the center's this way. That's a positive one. But this one has the center in the middle of the two shapes, so that's a negative one. Last question then. Stretch P with an x-axis invariant and factor 2. So P, if you're just using the axis, that's very easy. We can just draw our points and redraw them. So P has the points 2, -2, 6, -2, 2, -4, and 6, -4. So all those x points are going to remain the same. They're all going to be 2, 6, 2, and 6. But the y points are going to be doubled. So -4, -4, -8, and -8. And you can redraw those shapes. Now, you didn't need to do these points, but I find it useful to do the points. So our new points are here. 6, 2 -4, 2 -4 is here. 6 -4 is here. 2 -8 is... Oh, I've written one of those points wrong, have I? 3, it was 3. Sorry, 3 -8. 3 -8 is here, so it's here and here. So it looks a bit stretched looking. My diagram is over that, but here, that's it. Okay. Moving along. The volume of each cube. So we got a volume here. The volume of a cube is equal to this volume is equal to this volume. Okay, so the volume of this one is x times x times x, which is x cubed. And the volume of this one is 2x times x minus 2 times x minus 2. Peter, what are you doing? Yeah, exactly. Do some maths or watch this. So I have to multiply this out to show that it equals this. So this is just using algebra, our use of squaring and multiplying brackets. So I think I get this if I multiply this out correctly and then multiply it by 2x. I get 2x cubed minus 8x squared plus 8x. Bring everything to this side. So 8x cubed. I'll actually bring everything over here. 0 equals, bring this over, it subtracts one of the x cubes. And that's it. So I've done, if I just subtract this over this side, I subtract it from that. All right, on the graph, sketch this. So this, I can just do my calculator. Turn it on. Clear out anything you had before. And just type it in. Make sure my window is what I want it to be. So up to 7, it's from 0 to 7.5. And from negative 40 up to 40. All right, so that's graphing it for me. This doesn't look right. Something's wrong. Okay, let's look at this again. I've typed something in wrong, I think. Oh, yes, I haven't put, that's negative. Let's graph that again. Okay, so it looks like this. Something like... Okay, so that's my sketch. Part 3 then, find the volume of the cuboid. Okay, so the volume of the cube is when these two equal each other. I think we did this with Anissa and Priyanka the other day. Where do they equal each other? Where x cubed equals this side. 2x cubed minus 8x squared plus 8x. Where that equals that, they are equal. So there's a couple of ways I can do that. I can actually read that off this graph, but if I didn't know that, I can just draw these two and find out where they cross over, and that's where they equal. Or I can just find this point where they're 0 on this graph, because I've combined them. Let's pretend like I didn't have this one. Let's just find it from scratch. X cubed, I can just draw pretty straightforward. And then the other one was this one. There's the two volumes, and I just see where they're equal. Oh, not that. Okay, I graph it. I'll see where they're equal. Maybe it won't cross on my somewhere here. Looks like they're here. How do I find that? Well, I just press second and then go down to number 5, intersect. I want to find where they cross over. It's somewhere in this area. It's not very clear, but the calculator will find it. 1.17. So where x is equal to 1.17. What does that mean? That means that they're equal where that's the only place where the volumes are the same. So what are the volumes? Well, I know x is 1.17. The volume of this would then be 1.17 cubed. There may be an easier way to do this, but I haven't thought of it. And I get 1.6. 1.60 rounded. Okay, units cubed. Okay, that was very difficult. Yes. How did I find where they intersected? Well, what I did was I graphed the two originals from up here. I graphed this one, and where they cross over is the point of intersection. So when I looked at it on the graph, it crosses over somewhere here. So then I press second calc, and I go down to intersect. And the calculator will find where they intersect. That's how I found where they intersect. So that's the only place where the x values are the same. Yeah. Okay. Okay, so some algebra now. So I think that's the major tricky questions done, maybe, hopefully. Some algebra, how to factorize some brackets. We'll have to remember how to do that. 3x and x here. The 3x has been split up, so I'm going to split up. Oh, it's Aussie. 2 and 2 maybe, because 4 is 2 times 2. The way I check it is I check how I make this middle term of plus 4x. If this is plus and this is minus, I make plus 4x in the middle. So this is plus, this is minus. Is this my answer? No, I got to let them both equal to 0. I think this gives -2 when it equals 0. This one gives 2 over 3 when it equals to 0. So I may have done that quickly, but you need to practice your quadratics. Solve simultaneously these two equations. I'm going to multiply the first equation by -2. So I get -2x plus 6y is equal to -8. Why did I do that? Well, because now the y's are going to cancel each other out. These are just canceling if I add down. This becomes 3x, and this becomes -15. So x must be -5. If x is -5, I can find y. Just take any of the equations. Let x be -5. Add this over here. I get 9, so y is going to be -3. Next question, rearrange the formula, x in terms of y. So start off, maybe y minus 1 is equal to 2x squared is the start, or plus 1, sorry. Add the 1 over here. Divide by 2 is equal to x squared. So I'm trying to get x on its own. So the only way I can get rid of this square is to square root both sides. So I end up with root y plus 1 over 2 is equal to x. Plus or minus? Okay. So I try and let x equals. Next question. We're on to another. Show the total value of simple interest. So 450, simple interest 0.035 multiplied by 5 years. Okay, I get 78, 75. If I add the 450 onto that, I'll get the answer that they're looking for. Next question. Sorry. Okay. Next question. Okay, so we know the value of this investment is this. It was 450 put in. It was 5 years, but we don't know the compound interest rate. So we're going to put x to the power of 5. 5 years has to go as a power if it's compound interest. How am I going to find what x is? Well, divide by 450 both sides. So 530.6 divided by 450 will get me 1.179 is equal to x to the power of 5. How do I get what x is? Get the fifth root of this. Press 5 on your calculator, go down to number 5 in math, and that is the fifth root, 1.179. And I get 1.03348. So what's the interest rate? It's 3.348 or 3.35%. Remember, the 1 is just 100, part of the 100% in the compound interest formula. Okay, next up we have this. So solving this, subtract 5x from both sides first is what I would do. So I have 2x plus 9 is equal to 17 now. Minus 9 from both sides next. I have 2x is equal to 8. Divide both sides by 2. I have x equal to 4. Question 11. The shop reduces all of its prices by 15%. How much did he pay for the jacket that has been reduced by 15%? So I multiply it by 0.85 for the reduction. And I get 55.25 is how much he pays. And next one. Oh, Annika, Stella, can you go to Dr. Rick's office, please, for something? Sorry. Yeah, I just got a message. I don't know. Not sure. After paying for the jacket, Jake has this much left. Work out as the total fraction of the money he had before he bought the jacket. So he had this much left, which means how much did he have at the start? I think you have to add that on to the 55.25 he paid first. 24.75. 80. Sweet. So what fraction is 24.75 out of 80? Oh, this is a bit of a pain, but it's 2475 over 8,000 if I line up the decimal places. I think I can divide both by 5, and I'll use my calculator to do this. 247. I could probably divide by 25, actually. I'll divide by 25. I get 99. 25, 8,000 divided by 25. Maybe you can do it in your head. 320. Can I simplify more than this? I don't think so. I can't think of anything. You can try, but I don't think so. Okay. In a sale, Amy pays this much for a coat was the original price. So 80.75% is 0.85. How would I get to 100%? Divided by. So 80.75 divided by 0.85 will get me back to 95. So 95. So divide if you're working backwards. One day the shop reduced the sale price by 10%. Calculate the overall is 100% if you want. 85% and 100%. Okay. So there's double reduction. So perhaps it'd be easier to start off with if something costs $100 and you reduced it by 15% and then you reduced it by 10%, what would be the overall reduction? You see what I've done? That was minus 15%, and then you minus 10% from that. So I'm going to do a double reduction here. So $100 multiplied by 0.85 multiplied by 0.9 is 76.5. So what was the overall percentage reduction? 2350. 23.5% reduction. Why? Because that would add it back to 100 if you subtract it from 100. Okay. Next one, some logs. Find log 525. So rewritten, log 525 is equal to x can be rewritten 5 to the power of x is equal to 25. So what is x? 2. 5 squared is equal to 25. No. I've done all I can do. You've done all you can do. So just chill out. Maybe pass by at break time. Okay, this one, find p. Okay, we got to use log laws to do this. The first thing I'm going to do is write this as 3 squared. Multiply up the 2. Not multiply up the 2. Just bring up the 2. Okay, so that's the third log law we can do. So this is just 9. How do I combine these? Subtraction of logs. Subtracting logs, I can do what? Divide, yes. 9 over 5 is equal to log p. And I think I've just done it now. So 9 over 5 is equal to p. So p is 9 over 5. I can leave it like that or do 1.8 if you like. Next one, the volume of a sphere. So we need to know the volume of a sphere formula. It's up there somewhere. 4 over 3 r cubed, I think. 4 over 3 pi r cubed is equal to 32 over 3 pi. Find the radius. So the pi's are going to cancel there on both sides. They're both divided by 3, so that would cancel as well. So we get 4 r cubed is equal to 32. So I can divide that by 4. I get 8. R cubed is equal to 8, so r must be 2, the cube root. Another log equation here using the log laws. Remember, if I see minuses, I know I can divide, but only when there's no number in front. So I'll get rid of the numbers in front first. I'll move them up. Log 4 cubed. This is just log x and log 2 5. So that's application of the third log law again. Right, so I need to subtract, so divide these. 3 to the power 4, you can, this would be without a calculator, by the way. So if you're using a calculator, it would just give you the answer, but try to do it without. 3 to the power 4 is, that's right, 81. 4 to the power 3, 64, yeah. So dividing, subtraction is division, so I've just kind of skipped a step there. So this is also going to be dividing, 25. No, not 25. 2 to the power 5 is not 25, my bad. It's 32. Now I have an equivalent statement. So this equals this. So 81 over 64 is the same as x over 32. So what's x? You can look at a straightforward comparison here. That's multiplied by 2. So that would be divided by 2, yes. So 40.5. Divide by 2. So you want to go this way, it's dividing by 2. 40.5. Question 15. Calculate the length of AB. This length here. Okay, so that's part of a right angle triangle. If I just take that right angle triangle out, I know that the hypotenuse is 150. And I know I have an angle of 55 degrees. I'm looking for the adjacent side. So I can use cosine. Cosine 55 is equal to x over 150. Make sure your calculator doesn't say radians before you do this. How do we do that again? Mode. I need to go to degrees. So 150 times cosine 55 should give me x. So it's 86. 0.0 or 86. Because calculate the bearing of D from A. So from A. So that means I need to find this angle because that would be a bearing. A bearing. It would be this whole angle all the way around. So I've got 70. I've got 55. I just need to find this last bit. And I have this triangle to do. And I use cosine rule because I got 3 sides. So 235 squared is equal to 120 squared plus 150 squared minus 2 times 120, 150 cosine the unknown angle. Let's call it A. Yeah, I could use the other one, but the formulas will only give you this one. So I'm showing you how to use this one. So I have to just isolate cosine A. Which I can do. 235 squared minus 120 squared minus 150 squared is equal to 2 times all this minus 2 times all this. So there's a few minuses knocking around, but I have a calculator. Let's work out this value. So that's 183,525 is equal to. Huh? I've written that down wrong, but yeah. That's going to be, it's okay, it can be negative. If it's negative cosine, it just means it's in the second quadrant and it's an obtuse angle. 2 times 120 times 150 is negative 36000 cosine A. So you just divide over by this and cosine inverse it. So second cosine inverse, I'm going to divide 18325 divided by negative 36000. I get 120.6. That's my angle. Oh, that's not the answer though. Sorry, I need to add 55 plus 55 plus 70. 246. All right, and calculate the area of the field. We're almost there. I know this is a long time. Calculate the area of the field A, B, C, D. Oh, man. It's going to be a half AB sine C a couple of times. So a half, this one is going to be a half 150. Oh, you can't see that. Half 150 times X times 55. Half 150, X we found out was 86 and sine 55. Plus this one is going to be this angle, which is 120. 120, 150, sine 120. I found 120 here. Okay, so these two added together will give you this area. I won't do it because it will take me a few minutes and we're almost done. I'll do the last question instead. Last question, some surds to finish off with. We had this in a practice test before, but I'll do it. Multiply this times this. Most of you maybe can do this quickly. 4 times 4 is 16. 4 times this is 4 root 3. 4 times this is minus 4 root 3. Plus 3, root 3 times root 3. Oh, minus 3, sorry. These cancel, and we're left with 16 take away 3, which is 13. Rationalize this denominator, multiply by root 7 over 7. That's 5 root 7 over 7. That's it done. And the last one then is multiply by root 6 plus 2. Well, we see if this works. Make sure it works in the denominator. Root 6 times root 6 gives 6 plus 2 root 6 minus 2 root 6 and minus 2. So I left with 2 in the denominator. Divide by 2, I get 6 root 6 plus 12, and that's my answer. Okay, that's them all done.